Derivation of coefficient of static friction mu s in learning activity 4. We first sketch segment AB equals x and vertical height y, and the free body diagram of the object on the incline. Here we have the plus x as going down the incline, negative x is up the incline, perpendicular to the incline is plus y, and opposite to that is negative y. Here we see that we have our free body diagram with FG. This is FG, the red arrow going down, and Fn perpendicular to the incline to the surface, and FF limit is our opposite to where the object slides. So since FG here FG is not along X or Y axis, then we get its components. So we have along the X is the FGX, along the Y is the FGY. So looking now at this lower triangle with theta here, because our theta is the angle from the ground to the incline. So theta is here in this triangle. We have the trigonometric function sine theta equals opposite side, which is FG sub x over hypotenuse FG. On the other hand, looking now at cosine theta, we have equals adjacent side of theta is FG sub y and hypotenuse FG over hypotenuse FG. So sine theta equals FGX over FG. Cosine theta equals FG sub y over FG. We will now write the summation of Fx and Fy for this free body diagram. We have the summation of Fx, sum of all forces along x, equals, you see here that Fg sub x is positive, going to the plus x, down the incline. Opposite to that is FF limit. Equals, we ask ourselves, is this object accelerating along the x? Since in our learning activity number 4, we are getting the mu sub s, or the coefficient of static friction, wherein the maximum friction that holds the object is when the object is about to move. So here our object is not yet moving. It is just about to move. So equals 0. On the other hand, summation of Fy, sum of all forces along Y, plus going to the plus Y is Fn, and opposite to that is Fg sub Y equals 0. Target here is to get our mu sub s. So target is to derive or to obtain the expression of mu sub s from our setup or experiment. We have mu sub s is equal to ff limit over fn. This is from our equation 4.7. So we will get an expression of ff limit and ffn from our experimental setup so that we can obtain mu sub s experimentally. So ff limit, looking at our here equations, we have ff limit in equation in the summation of fx. So we are going to use this one. So using summation of fx to get ff limit, I'll copy fgx minus ff limit equals 0. This one. Just copying this one. So ff limit, we want that to be positive. Transfer to the other side. We have fg sub x equals ff limit. Now recall our fg sub x, the trigonometric equation that we had. Fg, this one, sine theta equals fgx over fg. So but sine theta equals fgx over fg. Transposing this, cross multiply. So fg sine theta equals fgx. So fgx is fg sine theta equals ff limit. But fg is just the weight equals mg. But we know that fg is just the weight equals mg. So this is mg. So mg sine theta equals ff limit. So for now, this is as far as we go. Ff limit. Next is we're going to solve now for fn. This fn. So looking back at our equation, we have here summation of fy equals fn minus fgy. So we get this fn. Getting the expression of fn using summation of fy. To get fn. We have there fn minus fgy equals 0. So fn equals, this goes to the right, fgy. But what is fgy? We have here in our trigonometry, cosine theta equals fgy over fg. We'll use that. But cosine theta equals fgy over fg. Transpose or cross multiply. So fg cosine theta equals fgy. So fgy here is fg cosine theta. So fn equals fgy equals fg cosine theta. But again, fg is just weight equals mg. So fn is fg is just mg cosine theta. This is now our expression for fn. So fn is mg cosine theta and ff limit is mg sine theta. Ff limit is mg sine theta over fn is mg cosine theta. M over m is 1 and g over g is 1. We are left with sine theta cosine theta, our mu s. But sine theta over cosine theta, it is just tangent theta. This is a trigonometric identity. Sine theta. So mu s is tangent theta. Looking now, so mu s is tangent theta. Let's now look at our situation. Theta is here. This is theta here. And this is also theta. But now we focus on this theta under the incline. Tangent theta is equal to opposite side over adjacent side. That's our trigonometric identity. So looking now at theta here, opposite side is actually the y, the one you measured using your ruler from point B to your inclined vertical height y over adjacent side of theta is x. The one you measured also from point A to point B, that's x. So this is now our expression for tangent theta equals y over x. Tangent theta equals y over x. Thus, mu s equals tangent theta equals y over x. Thank you for listening.